Today, we're doing all of chapter 12.
What?
Yep. Good news is, all you really need is your calculator.
We write anything down or what?
Yeah, you might want to write a little bit down, but it's not a lot of calculation going on. Calculator is going to handle most of it. If you have your calculator with you, you should take it out so you can follow along. If you don't have a calculator with you, you should sit next to somebody that does have a calculator that you can at least look on over their shoulder with. Or borrow a calculator from somebody that has one that you can look at. Yeah, you need a calculator, homie. All right. So we got a little bit of vocab to get through, and then we'll get into the meat and potatoes of what we're doing and show you how to do it. So a little review from last year. Start by just defining what we mean by a polynomial or a polynomial function. So a polynomial function is something where you have some some coefficient times a variable to a power, and then plus some other coefficient times some variable to different power, etc., etc., etc. The thing to remember here, the coefficients in a polynomial can be any real number. The exponent, though, in a polynomial must be non-negative whole number. No decimals, no negatives. Okay? When we talk about polynomial functions, we like to classify them by the degree. The degree is the biggest exponent on a variable. So this example up here would be a degree n polynomial. And then the leading coefficient is the coefficient on the biggest degree term. That's called the leading term. So here the leading term, an x to the n. And the coefficient there is an, so that's like the leading coefficient. Everybody good? Sure. All right. Let's check our vocab. All right. A is f of x equals 4x to the 6 minus 5x squared plus 2x minus 1. Is this a polynomial, yes or no? Yes, why? I heard yes and then some mumbles because I didn't really hear anybody enunciate. Can you say it loud and proud? One of you people that said yes? Anybody that said yes? Because there's two exponents. Were you not listening? We just told you how to tell. So what you need to do is you need to look at two things. All right, the only operations going on, multiplication, addition, subtraction, and exponent, right? Everybody agree? There's no like radicals or logarithms or sines or cosines or weird stuff like that going on, right? Are all the coefficients real numbers? 4, -5, 2, -1, those are all real numbers, right? Next thing, the exponents on the variables, are those all non-negative whole numbers?
Yes.
Then it's a polynomial, right? That's all we need to look at. Since it's a polynomial, what's its degree?
6.
Great. And what's its leading coefficient?
4.
Great. B, is that a polynomial? Square root 3 times x minus 6. Why do you say no? Well, so what? Square root 3 is a real number, isn't it? Yeah, this is a polynomial. Now, if that square root bar extended over the x, then it wouldn't be a polynomial, because now you're taking the square root of a variable. But the way it's written, that is a polynomial. What's the degree then? 1. Where'd you get the 1 from? It's x to the first, right? Awesome. And then the leading coefficient then is? Good. How about C? Is that a polynomial? Emily, you're shaking your head no. Why not? Great. Perfect answer. Everybody cool with that?
Yes.
Okay. Part D, is that a polynomial? No, why not?
Negative x over.
Yeah, good.
Oh.
I tried to sneak it in there and hide it for you. Everybody happy? Okay. Sometimes when we name polynomials, we name them by their degree. Does anybody remember what like a degree 2 polynomial would be called? We would have talked about it last year a whole bunch.
Quadratic.
Yeah, right? Degree 2 means you have an x squared. That means it's quadratic. Or the biggest thing is the x squared. Degree 1 is linear. Degree 0, well, that's constant, right? Because there's no bx to the 0, which is just 1. And then if you have no degree, well, that's just 0. Well, that's a 0 function. Again, just a little bit of vocab there. Not super duper important, but like we should have a common language to talk about things. The next thing we're going to talk about is if I have two variables and I want to measure the strength of the linear relationship between them, how do we do that? And let's just say those two variables are x and y. So to do that, we use correlation, which we abbreviate with the letter R. So when we talk about R is a real number that goes from -1 to +1. If that correlation, or if that R is negative, that means the correlation is negative. And that means the same thing as having like the data has like a negative slope to it. If that R value is positive, we say that's a positive correlation. And that's like the data having a positive slope to it. Yeah.
Since, are we going to have a test on chapter 12?
Yep. Now, when we talk about the strength of this linear relationship, the further we get from 0, the stronger that linear relationship, or the implies a stronger linear relationship. So maybe from like -1 to -0.9, or from +0.9 to +1. We'd say that's strong correlation. Say from -0.5 or -0.9 to -0.7, or from +0.7 to +9. Probably call that moderately strong correlation. Between 0 or -0.7 and 0 is probably weak, and 0 and 0.7 is typically weak. And at 0, we'd say there's no correlation at all. Is everybody okay with like kind of the numerical dividing lines that we're kind of giving here? One special thing to say, if you get a correlation of exactly -1 or exactly +1, what that means is the xy's, the two variables, if I plot them and drew a line, you could draw a line that went through every single point in your data. One straight line hits every single data point. What it's saying is that your data is perfectly linear, that these are actually points on some line. Now, if it's like -0.99, that's real close, but it's not exact. Everybody's okay? All right. Let's test this out with a little example here. So here's a graph of two variables, right? What do we call this kind of a graph? Scatter plot. Great memory. That's what you call a scatter plot. It's just a bunch of points, right? It says describe the correlation based on the graph and then give an estimate for the R value. So let's describe the correlation first. First thing you want to do is say, is this negative or positive correlation? Negative. How can you tell? It's going down as you move from left to right. Now we should talk about the strength of this linear relationship. Is this weak, moderately strong, very strong? What do you guys think? Yeah, I would say moderate to very, somewhere in there. I think either one I would accept. And as a result, we might estimate that R value to be what? Well, not 0.7, because it should be negative, right? But I would say anything, anything in between there I would accept. Everybody's okay? If all we got is a picture to make an estimate of, like whatever, as long as it kind of supports what you're saying and it seems reasonable-ish, I'm not going to complain too much about it. Everybody's okay there? Now, in practice, we can do a lot better than just looking at a picture and kind of guessing at the correlation, right? Let's show you how to get the actual number for that. And we can do some other stuff along the way. So here, we're going to be using our calculator. So if you don't have your calculator out yet and powered up, get her out and get her powered up, because that's about what we're going to be doing. So let's say we have this data set. What this data set represents is the price that we're charging for a canned good and the number of those canned goods we sell in a given day. It's come from like a shop or something. In general, what do you notice as the price of the can goes up? What's happening to the sales? They're going down, right? Which is kind of what we'd expect. The more expensive something gets, the less you probably sell of it. Everybody's okay? All right. If you were to guess which one is the independent variable and which is the dependent variable, what should the relationship be if we just kind of use common sense here? Jacob? Great. Yeah. So the price is our independent variable because the sales depend on the price, right? So this should be like our Y variable. Everybody feel okay doing that? Just kind of using some common sense, thinking about how things are related, right? All right. So first thing we're going to do, we're going to get this data into our calculator so we can look at a scatter plot. To enter data into our calculator, we're going to begin by pressing the Stat button, which is kind of right next to the left arrow. From there, we want to be in the Edit tab and select the Edit command. So press Enter there. Now I have some data already in my calculator. Most of us probably don't. If you do have data in your calculator and you want to get rid of it, what you do is you need to move your cursor. See, my cursor right now is on this 88. I'm going to move it up so that it's on the title of that column, the L2. And I'm going to press clear, not delete, but clear, and then the down arrow, and it'll wipe the entire column for me. And I'll do the same thing for L1. I'll move up so my cursor's on the L1, press clear, and then the down arrow, wipe the entire column. That stinks. Just use list 3 for now, and I'll help you later. All right. Now what I'm going to do is I'm going to enter the price per can in L1 and the number of cans into L2. So to do that, I just put my cursor on the first spot, type in my number and press enter, and then just keep on going. Do that now. If you find you make a mistake, you can use your cursor to go back to the spot you made a mistake. And if you press enter, you can just type over whatever the mistake was. Like, for example, if I, oops-a-daisy, I typed 18 instead of 183. If I just move my cursor back there and press enter, I can just type in 183 now and just update it. Right? Anyone still entering their data? Fantastic. I'm going to exit out of here by pressing second and the mode button. And now what I want to do is I want to turn on the scatter plot. To do that, I press second and Y equals. That opens up the stat plot menu. I'm going to pick plot 1. I'm going to begin by turning that on, so I'll press enter so the on is highlighted. For the type, scatter plot is the first option. It's the only option we're going to use in this class, so you can ignore all the other ones. We need to indicate where we typed our x variables and our y variables. I typed my x's into L1. I notice that's the default there. And I typed my y's into L2. If you accidentally deleted your L2 and did things in L3, if you press second and the number 3, it'll put an L3 there. I don't want to do that because I didn't delete my list 2 on accident. But if you did do that, yes, sir.
How do I open it?
Second y equals. Yep. Everybody feel okay? I'm exiting out now, second in mode. To graph this, I'm not going to press the graph button. Instead, what I'm going to do is I'm going to press zoom, and I'm going to scroll down till I find the command zoom stat, and I'm going to select that one. There's my scatter plot. Everybody should have the exact same scatter plot because we all entered the exact same data, and the zoom fit should have picked the exact same window for us. Yes, Aiden.
Do I use the data and graph wizard in the science schools on the calculator?
I have no idea because I've never used that before.
So it's, if you update it to the newest version, just on these ones, you can go to like the data and graph wizard, and then you can go to data and then change it and then type things. And you can just go to like stat, and it'll graph it exactly like that.
Okay, sure. Doing the same thing?
Yeah,
That's fine.
Same thing.
Okay. Everybody's okay with the scatter plot we got out of here, right? Let's get our correlation out of this, right? So one thing that we'd want to potentially do with a data set like this is we might want to create a model that's going to describe this data so we can use that model to make a prediction, right? The process of doing that is called regression. If the model that we're going to build is a line, it would be called linear regression. When our calculator does a linear regression, it will also give us the R value at the exact same time. provided that our calculator is set up to give us R values. So the next thing we need to do is set up to make sure our calculator is going to output the R value when we do a regression. So we should only have to do this one time unless you reset your calculator's memory, or the memory gets reset because battery issue or whatever. So the command we're looking for is called diagnostic on. So I'm going to exit out of here, so second in mode. And then I'm going to open the catalog by pressing second and 0. The catalog is a list of every command on your calculator in alphabetical order. The command we're looking for is diagnostic on. So we could scroll all the way down there, or if you notice above some of your buttons are letters in green like A, B, C, D, etc. If I press the button with the D under it, it'll skip me all the way down to the D's. That's a whole heck of a lot of less button pressing for me. And then I'm scrolling till I find diagnostic on. Everybody's okay? Anybody still looking for diagnostic on? Okay. Once you found it, press enter. It'll paste it onto the home screen. And press enter again and it says done. Should never have to repeat doing that process as long as you're using the calculator you're using today and you don't reset your memory. Once you've done this once, even if you turn it on and off or whatever, that part stays until you reset your memory. Everybody's good? Okay. What I want now is to do that linear regression that we had talked about. So again, I'm not going to do this by hand. You don't need to know how to do it by hand. We just need to know how to ask the calculator to do it for us. To do that, we're going to press the Stat button. But this time, instead of being in the Edit tab, we're going to move over to the Calc tab. And this is where all of our regression options live. So you see here's a linreg, quadreg. Reg is short for regression. Cubic reg, quartic reg. Keep on scrolling down. You have another linreg. LNreg is logarithmic. So that's a logarithmic regression. Exponential regression, power regression, logistic regression, sinusoidal regression, manual fit. I've never used that before. I don't really know how. I've never tried. The one we want, though, is the very first linreg, because our data looked like a line, right? So let's use that option 4. To use this option, again, it requires 4 inputs. We have to tell the calculator, where did you put your x's? Well, I put mine in L1. That's the standard, or that's the default. I put my y's in L2. Well, that looks good. For us, the frequency list is always going to be blank. We're never going to put anything there. And the last option is store the regression equation. What that option is doing is the calculator will save that equation that's going to make somewhere so we can use it again later. We do want to do that. That sounds like a good idea for us. The place we're going to put that equation is going to be in one of the y equal spots. Let's just put it into y1. So to get the y1 there, we're going to press the vars button, which is right underneath the down arrow. Vars is just short for variables. Since we want y1, we want the y variable, so we're going to move over to the y vars tab. In this class, our calculator will always be in function mode. That's all we'll ever use. And there's my y1. So next to store reg EQ is y1. I move my cursor down onto calculate and press enter. So we should all gotten an output that looks like this. Because we use the exact same data points, we should get the exact same set of numbers. So what is this all saying? It says for the calculator made us an equation y equals ax plus b, right? Looks like slope intercept. It tells us the a value should be negative 104.68 yada yada yada. That's the slope. And the b value should be 329.28 yada yada yada. That's the y-intercept. And then it tells us the r, that's our correlation, is negative 0.96. So pretty darn good, right? It's very close to -1, which is great. Very linear. We don't know what an R squared is yet. We'll talk about it a little later on how to use an R squared, or what that means anyways. Everybody feel okay? Hit graph now and take a look. What's new to our scatter plot? We have a line of best fit. So the calculator, because we had stored that regression equation, if you look at y1, what do we notice is there? That's the equation that the calculator just made for us, right? It copied it all right there for us, which is so nice of the calculator to do, because that was like a lot of decimals to have to transfer. I love that it did that for me. Very kind, Mr. Calculator. Everybody's okay. So let's review what we've done. We've shown how to create a scatter plot. We showed how to find an R value and at the same time create a regression equation. What we're going to talk about next is how to then use that regression equation to make predictions. So let's say we wanted to predict the number of cans sold if we charge, say, $1.80 per can. So what are we really asking you to do there? We want to plug 1.80 into the x in that regression equation that we just made. We could do that by hand, or if you ask nicely, the calculator will plug that number in and tell you what it ends up getting. Let's do that, right? So I'm going to exit back to the main screen. And I remember I stored my regression equation into y1. So what I need to do is tell the calculator to plug 1.8 into the equation y1. So to do that, I want the y1. So I'm going to go back to the vars, over to yvars, select the function option, select y1, and then I'm going to write this like a function notation. So I'm going to have a parenthesis and then type in 1.80 and then close my parenthesis. Like it's a function notation, like f of 5 or something, where it tells you to plug 5 in for the x, right? If I press enter, I get about 141 cans. Everybody okay there? So there's actually two types of predictions we can do. So notice that 1.8 was in between the biggest and smallest x values in my data set, right? That type of prediction is called interpolation. If we had instead asked to predict the number of cans sold, if we say charge $3.50, so we can just do the same thing, right? So if I want that y1 again, I can just move my cursor up here and press enter so I don't have to go through all those menus and just re-update that to be 3.5. Is everybody okay with me doing that? Saves me a little bit of time. Whoa, what the heck is that? Does that make any kind of sense? How are you going to sell negative 37 cans? You don't. So this type of prediction, where we use an x value that's outside of the biggest or smallest values in my data set, is called extrapolation. And typically that can lead to wacky answers. Extrapolation typically is unreliable because in reality, if these cans get too expensive, how many am I going to sell? Just 0, right? I can't sell less than 0 cans. And if I sell my cans for nothing, like if I charge no dollars for them, how many should I sell? infinitely many, right? As many cans as I have, I should be able to sell if I'm giving them away for free, because some crazy person's going to be like, free? I'll take them all, but it's green beans. You don't even like green beans. Yeah, but it's free, right? Like, people are nuts. When you put free attached to something, someone's going to take it from you. Everybody's kind of okay with that. So extrapolation, even though our data set is linear for this section, who knows what's happening after that, right? So extrapolation, you can get wacky, unreliable results or unreliable predictions. And the further you get away from your bounds, your highest and lowest x, the less reliable that prediction becomes, right? Everybody's cool? Kind of gets what I'm saying, Kate? Of course. What if we instead asked, say we wanted to find out how much we should charge if we want to sell 100 cans. This time, what are we looking for? An X value. What are we given is a Y value, right? So this would be like a plug 100 in for Y, and then we'd have to solve for X, right? Our calculator can do this for us too. We just have to ask it nicely. So the easiest way to do this is to do it graphically. So we're going to press the Y equals button. And in the Y2, we're going to put in that new Y value, 100. And then I'm going to hit graph. What am I looking for? The intersection between my regression line and that line Y equals 100. How do I find the intersection? On my calculator, second and trace. And which command do I want from there? Intersect. So first curve, well, that's the regression line. That sounds good. Second curve, well, that's the straight line. That sounds good. They only intersect once, so my guess doesn't really matter. The calculator will find it. About $2.19 is what it says. How do you guys feel? So far, so good? Great. So remember, when we looked at our choices for regression equations, there's a whole heap of them, right? How would I know if I wanted to do, like, if I didn't want a linear one, right? What if I wanted to do a quad one? What would our data set look like? Anybody remember what the graph of a quadratic looks like from Algebra 2? You graphed them a whole bunch of times. Yeah. Isn't it what? Yeah, like a U. Right? Could that U open down also? Sure, that's fine. What if it was... What if instead of quadratic, what if it was cubic? What if it was degree 3? Should have like 2 U's, right? You guys okay there? What if it was exponential? You guys remember what an exponential curve looks like? Yeah. So it starts off flat and then gets real steep. You guys remember that? Vaguely, maybe. Or maybe more than vaguely. Who knows, right? I'm missing linear. Okay, what if we have something like this? That's going to be like a power function. Now that was a name maybe you don't remember from Algebra 2. So let's talk about what we mean by a power function here right quick. So a power function is something that can be written in the form f of x equals k times x to the a. Mr. Kulik, isn't that just like a polynomial? No, because there aren't any restrictions on a other than it can't be 0. So a can be negative, a can be a decimal, can be a fraction. Could it be a whole number still? Yeah. Everybody's okay? So vocab-wise, the k, that coefficient out front, we call the constant of variation. The exponent here, the a, we call the power for our power function. And in words, what we would say is we'd say f of x varies with the 8th power of x. So let's just look at a couple of examples here of like just using the words. So let's say the circumference of a circle varies with the radius. So I would say C equals K, and then it doesn't say power of the radius, right? So I assume it's going to be 1. Now, who from geometry remembers what K should be? If we're talking about the circumference of a circle. What's that formula? 2 pi r. So really my K, my constant of variation is 2 pi r, and my power would be 1, right? Let's do another. We doing okay with the words though? Sometimes the words are the hardest part for us in math class. Here it says the area of a circle varies with the square of the radius. So area varies square of the radius. Should be like that, right? Everybody's okay? Now, from geometry, who remembers what the K has to be here? What's the area formula for a circle? If you remembered circumference, how do you not remember area? Dude, it's pi r squared, guys. Just pi r squared. So pi would be like my constant of variation, and 2 would be my power. Everybody's still doing okay, other than like Mr. Kulik, I don't remember any of my geometry formulas. All right. So what if we have here, this says the volume of an enclosed gas at a constant temperature varies inversely with the applied pressure. You recognize this one from chemistry? This is Boyle's law. Oh. You guys don't do gases?
2 years ago.
Okay. This is why if you're like deep sea diving, you have to exhale on your way up. If not, your lungs will explode because the pressurized gas will expand and you'll burst like a hot dog in a microwave.
Yep. True.
Pressure. The higher pressure at the bottom, the pressure goes down as you come up and the gas in your lungs expands and you pop like a balloon, which is terrible to think about. All right. So let's say the volume of a gas at a constant temperature varies inversely with the applied pressure. What power is inversely going to mean? -1. Yeah, good. So again, constant of variation, power. Everybody feel okay doing this? It's not bad, right? You just take a little bit of practice, getting used to the vocab. Let's do, oh yeah, so okay. So that's about power functions, but we have these these other 4 possibilities, right? These other 4 possible regressions. And obviously there's more listed there, but like we're not going to worry about anything past this really. So yeah, I could look at the picture and tell what's going on, but what if I have just like this much of it? Doesn't that look like, don't all of those kind of look the same if that's all I got? Is there a better way to tell the difference between these? Which one is kind of the best fit? Yes. Yes, we can do that. So we can use what's called a coefficient of determination. Which is r squared. Remember when we did the Lin-Regan, we got the r squared value and we didn't mention what the heck that meant? That was a coefficient of determination. R squared goes from 0 to 1. The closer you are to 1, the better their fit. So if I wasn't sure, I could do several regressions and take the one with the best r squared value. And that's one way to kind of make a decision as to like, okay, I have lots of choices. Which one should I choose? That's one way. Okay. Let's do another example of kind of doing this process on our calculator, but instead of doing a Lin-Reg, we'll be doing a different type of regression, but all the steps otherwise are going to basically be the same. So it says, consider the given data table. Use the data to create a scatter plot. Stop. Let's do that right now. Get your calculator out. Remember how to get to places. I'm counting on you guys to try it on your own. I'm going to be doing it in the background while you guys are doing it too. Do it. Okay, just do it. If you don't know what to do, ask your neighbor who's a good listener, or maybe Kate or Miriam that took stats that probably remember at least this much. Right? You guys do this in first semester, I'm guessing? Yeah. Because are you still in stats? Or did you both quit?
I quit.
You quit, Kate stuck it out.
Yeah, I still remember that.
This is good to remember. Look, it's coming in handy right now.
For real. Crazy.
It's just about using your calculator though, like, right? Like this is just calculator literacy, really.
I thought you were going to make us like into it, not with coding.
Oh, no. In this class, no way, Jose.
More flashbacks.
Okay, and then we got the
So that's what my scatter plot looked like. I'll pause here for a minute as you guys are working through yours, and we'll do the net, and then we'll do the.
she was in bed. I got a line through
You might, it's probably because of the y equals still. You still have the model from the last one still in there. I deleted mine out of there. But it then says, and create a power regression curve to model the data. Okay, so this time we're going to do a power regression instead of a linear regression. So go ahead and do that. I would, because we're going to need it to do the next part.
For your egg, that's 200. I got 0.2. Yeah.
Mine is 0.200.
Oh, okay.
It didn't say 0 point, but there's a point there. It's just,
I didn't see the point. So then
it's you're far away.
go to stack. And then go to the right, go to out. And then go all the way down. No power right. Because it's not.
Because the directions say to do a power regression.
No. It didn't work. What's wrong with it? I just did it. Wow. Just why one? Just no.
Yes.
Didn't work.
Look at that beautiful fit that we got. Wow. It's a thing of beauty right there.
Oh, whoa. Oh, you have, why do you only have, why do you not have your others? Is it in the wrong place?
Yeah,
It's 10,000.
I thought that was a point, not a.
Oh, yeah, that makes a big difference. And the last part then says, use that curve to estimate the orbital period of Neptune, which is 4,497 gigameters from the sun. What am I doing with that?
Plugging her in.
Plugging it in.
How do you get the line?
He needs to turn his diagnostic on. He was snoozing for that part. You remember how?
Yeah.
You're awesome.
Does it matter? I got something like this, but it's like extremely close. Like with that, like I don't know how it's like so close, but it's still just a little off.
Wait, would you have the same numbers as him? Yeah. It's strange.
I think it's fine. I don't know why it's giving you something. Why I gave you something different. That's weird, but it's close enough.
Okay, you probably just put the numbers in wrong, but you did it right on there. Yeah.
What is this number saying? 60,142. What is that?
That we're awesome people.
When they say orbital period in days,
That's how many days it takes.
for
1 cycle.
1 year, basically, one trip around the sun. So if you lived on Neptune, 1 year is 60,142 days. Yeep! It's a long time. Right? Earth, it's 365.2. What's with the 0.2?
We're just having fun here.
What? That's why we have a leap year, because every 5 years or whatever, you have the leftovers to make one extra day. Every 4 years, then. It's more than 0.2.
When's our next leap year? It's this year. This year's leap year.
Dang it. It's an extra day of school.
I still don't know how the leap year works.
I just explained it.
For the sting, we had to finish the floor, which is the lid run, so we did everything right, you started to go down the color. Swallow it down. It's past 4, it's like a.
All right. How do you guys feel? So far, so good? How's your calculator literacy coming? Here, let's do another. Get your calculators out. Get going. We're doing another.
Yeah, okay, on the top there. Yeah, the top is on the bottom.
What?
Sorry, that's wrong.
Uh-oh. I missed one. Dang it. I hate when I do that. There it is. There we go. So there's,
Is it just the normal lid run that we're doing?
that's what it says, linear regression.
Okay.
It doesn't even ask for a plot. It doesn't ask for a scatter plot. Asks for the linear regression, the correlation, then a prediction.
I already messed up. Why are there so many numbers? I can't see half the numbers. 2.4, 2.6. Why do I have 3? Why don't I have 2.8? 2.8, 3, 3.2.
The X's are just going up by 20 cents, dude.
I know, I'm just, it's not the day for me today. Okay. 33.
And there's the last part. Sorry, I was moving that and you were trying to read. I probably didn't help any. What are you guys thinking on this? Is this getting...
What's the linear regression correlation?
That count,
Is that just
line reg, bars,
Oh, I just put, yeah.
y bars, function.
So the lin reg would have been y equals negative 153 blah, 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 x plus 73622.5.
okay?
And the correlation coefficient is this negative 0.98053, yada, yada, yada.
Okay.
Yeah. With the 2, would you put in like y1 negative 2 because it's dropping 2
No,
You just put 2 and 4.
right. Because 240 was the first price. So when we say drop to $2, it just means like $2 is the new X value. It's not dropped $2, it's dropped to $2. You know what I mean? It's okay. We're just talking, right? Just grammar. Grammar's hard, guys. Way harder than math. You guys are all crazy. Math has beautiful, wonderful rules that exist without exception. Grammar is full of exceptions. It's all exceptions.
And yet everyone can understand it.
I can't. If you tried to ask me to teach you grammar, I'd have no idea even how to start. It's an action word. Sometimes. Sometimes. Sometimes those action words are nouns, though.
Action.
Conjunction.
It's a word that sounds like it's sound, or right?
Like
boom.
Huh?
Like boom.
Yeah.
Oh, yeah. What's the one where it's like race car, spelled race car from the back?
That's a palindrome. That's spelled forward and backwards.
So you do know that.
I know vocabulary. I know what words mean. I don't think palindromes have anything to do with grammar. You write down a sentence and ask me, tell me what the adverb is, and I'd be like, I don't know. Is this past perfect? Is it present perfect? Like, where should the comma go? What if the comma's here but not here? It's like, oh my goodness, this is all
Do you believe in the Oxford comma?
always.
Yeah.
More commas is better.
Yeah. People who don't use the Oxford comma, like especially.
Wow,
Okay.
that's rough.
Is that the entire thing?
Try this one. Try this one. Yeah, this is it for chapter 12. We've seen all of chapter 12. This is it. Can you use your calculator?
When's the test?
Well, before we do a test, what do we have to do?
A quiz.
When should that be?
Friday.
Yep. What else is going to be due on Friday?
Not you.
What else is going to be due on Friday?
Half sheet.
Half sheet. What do you probably want to put on your half sheet?
The directions for the calculator.
Yeah, just calculator steps on how to do things, right? Or maybe a little bit of light vocab if you don't feel good about the vocab piece. Sure.
If we're not going to be here Friday, can I just give you my half sheet earlier in the day?
Or you can take a picture and email it to me. That's okay too. But again, like, I'm giving you the forewarning that, like, half sheets on Friday, there's not much to put on here. It's going to be like some calculator instructions to yourself on, like, what to do or whatever. Maybe a little light vocab stuff. If you're Miriam, you probably don't need a note card at all. Or Kate, right? That are like, yeah, I did this all year in stats. I know the heck out of the steps to do these things.
Oh no, I have an extra number.
Oh, that's the worst, isn't it?
I'm not redoing it. It was like I missed a number like the second one.
Oh, that is the pits.
Yeah. I'm just almost.
Yes, sir.
I turned my homework in last night.
Did you send me an email?
Nah, did I?
If you do that, I'll make sure I go back and check it. Or when I go back and check, I'll make sure I update it.
Yeah.
Might not be the next day or whatever, but
I'm not worried about it.
I'll get it. Look at that beautiful fit. Oh, lovely. Now notice here, it's asking us predict the year when we'll reach 450,000 patents. If I go and I graph 450, I don't see the horizontal line for 450 because the window is too short. So I need to move my window up some. So I'm going to find my Y max, and I need to make that number bigger than 450.
Good afternoon, Notre Dame. As we end our day together on this Ash Wednesday,
Oh, and it's not far enough over either.
and reflect. Go ahead and close your eyes and take a deep breath. Take a brief examination of how you are feeling at the start of this Lenten season. Do you feel close to God? Or are you feeling a little bit distant? What will you do this Lent to let go of the things that are distracting you from your relationship with God